Good afternoon, and welcome to STG401, the Deep Dives and Best Practices session for Amazon S3. My name is Umair Gilani, and I'm a product manager on the Amazon S3 team. And I have with me Hisham Baz.
Good afternoon, everybody. My name is Hisham Baz. I'm a solutions architect with AWS. I work with our customers, helping them build high-performance, mission-critical systems.
All right, so before we get started, a quick show of hands. How many of you guys have worked with Amazon S3 before? Wow, quite a few. Well, if you haven't, no worries. It's actually very easy to get started. It is, after all, simple storage service. We have a lot of great documentation out there. You can use our simple REST interface to get started. You can also use the console to get data up in S3 and start playing around with it. Now, fair warning, though, most of the content today does assume working knowledge of Amazon S3 because this is a deep dive session. But we will be available for questions after in case you have some. So with that, let's get started. So we've had a busy year. In fact, AWS, last I checked until July this year, shipped over 350 significant services and features, and that's just half the year. And S3 is no exception. We've been working with a lot of you guys, our customers and partners, to make sure we enable you to get the most out of your data on S3. And one of the things that we've been working on, and we just launched a few weeks ago, we're very excited about, is a new storage class for S3 that we're going to talk about today, called Amazon S3 Standard Infrequent Access, or Standard IA. This is a low-cost storage option for data that is less frequently accessed, but you get the same great durability and performance that you get for S3 Standard to make sure that you don't have to ever worry about losing your data, or your users never have to worry about getting subpar performance or subpar experience. So we'll talk more about this new storage class. We also have a lot of customers who wanted to kick off workflows or perform actions when a certain event in their bucket takes place, whether new data gets added to the bucket or gets removed from their bucket. And a lot of these customers were either building proxy services or are trying to write code to poll and find out whether something changed in their bucket so that they can kick off that workflow. Last year, we enabled this new capability to kick off notifications when a new event, a new object gets added to your S3 bucket. This year, we're expanding this capability, and we enable you to trigger event notifications, not just on put events, but also on delete events. So when an object gets removed from your S3 bucket, you can trigger an event notification that you can trigger towards multiple endpoints. You can kick off the event notification on an SNS topic or an SQS queue so that you can kick off specific workflows off of that. Or you can trigger a Lambda function, which is code running in the cloud. No worries about running infrastructure or managing infrastructure. It scales dynamically. We'll, in fact, look at how you can actually use that in one of the examples we'll get into in just a second here. We'll also talk about the new cross-region replication capability that we added this year to Amazon S3. A lot of our customers, even though you get the great 11 nines of durability, wanted to have another copy of their data a few hundred miles apart, either to meet some compliance requirements or to perhaps move it closer to their end users so they get lower latencies and a much better user experience. And a lot of these customers were actually writing code to trigger and copy data to to a different destination bucket in a different region. With cross-region replication, you no longer need to do that. You can simply configure this policy on your bucket, and all new objects that get added to a source bucket will be replicated automatically to a destination bucket in a different region, which makes it much more easier to get that extra copy of your data in a different region. Now, security is our top priority, both at AWS as well as Amazon S3, and we always make sure that we add the capabilities that our customers ask for around that. And to that end, we added this new capability to establish secure connectivity from within a virtual private cloud, the VPC, to Amazon S3 without having to go over the internet, so your data never really leaves your virtual private cloud when you have to talk to Amazon S3. In fact, you get some additional control because you can decide which VPCs are allowed to talk to which S3 buckets, and which S3 buckets will accept connections from which specific VPC. So we'll talk about this new VPC endpoints for Amazon S3 as well today. Now, Amazon S3 is scaling at a very rapid pace. We regularly peak at millions of requests per second, and we have trillions of objects in S3. And one of the things we think about there is how do we help you get more insight and get more out of your data on Amazon S3? And a big part of that is really understanding what you have on the platform. What kind of data do I have? How is that data changing? Who is accessing that data? And so what insights can I get out of that? I mean, think about it. If you have a few 100 billion objects and thousands of customers trying to access that data at the same time. And to that end, one of the capabilities that we announced this year is new storage metrics for Amazon CloudWatch. With Amazon CloudWatch, you can get additional insight into your bucket by looking at the total number of objects and how that's trending over time. You can also look at the total number of bytes that you have stored in any given storage class, whether it's standard and frequent access, or reduced redundancy storage. And then you can see the trends changing over time. CloudWatch also allows you to set alarms on these metrics. So you might want to perhaps set an alarm on X amount of terabytes, and you expect to consume that in a given bucket. You can actually set up a CloudWatch alarm so you get an email notification when you pass that threshold, so you can take specific action on that. Another piece of getting more insight into your bucket and into your data is who is accessing my data. And this year we integrated with AWS CloudTrail, so you can get an audit log for operations that happen on your bucket. So you can now track who is creating my buckets, or who is changing policies on my bucket, when are they doing it, where are they doing it from, again, to get that additional insight to be able to demonstrate compliance and improve security. Also, a lot of our customers, specifically in enterprises, also customers who are hosting software as a service or websites and web services on S3, told us that for some use cases, it's easier for them to actually put their customer data in specific buckets. That way, they not only get to track billing for specific customers separately, but they can also potentially manage the different policies that their customers might want, whether it's lifecycle policies or cross-region replication or any other policy that their customer might want. And they can easily scale up by adding more buckets and then isolating their customer data by those specific buckets. We also have enterprise customers who are transitioning and moving thousands of applications onto AWS and Amazon S3. And in those cases as well, if I can isolate my HR data in one bucket and finance data in another, I can easily not only understand how much storage is being consumed and look at how much cost HR is running up versus finance, but I can also manage different policies separately. It gives me that nice little isolation. But for those use cases, by default, we have a 100 bucket limit on AWS, and this year we announced that we can increase that bucket limit. You can simply work with your support, AWS support person, or open up a support ticket, and we'll work with you to make sure we increase your bucket limit to meet your specific use case. Now, S3 is a huge distributed system, and a lot of our customers actually are building very complex distributed systems on top of S3 as well. And one of the things that S3 provides is eventual consistency when you update and remove your objects. So think about doing multiple delete operations perhaps on exactly the same key at exactly the same time. The system needs to be able to handle that. And one of the ways we handle this is providing eventual consistency. So no matter how many operations you do on any given object or set of objects in S3, eventually all clients and all consumers of that data will see a consistent state. That's true for updates and deletes. But there are certain workflows where it actually makes sense to be able to write a new object and then be able to read that immediately. Think big data workloads where you want to write a whole bunch of files onto your S3 bucket, but now your application actually has to wait for that eventually consistent state to be achieved, and that's a bit of a pain point. So this year we announced that for all endpoints in all regions on Amazon S3, we now have read after write consistency. So you can put in a new object on Amazon S3 and then immediately read that without having to worry about not finding that object. It will always be there available for you. So that's a very quick look at some of the things that we've launched and some of the capabilities that we've added to the platform this year. And we're going to talk about some of these in more detail in just a second here. But instead of walking through each one of these at the same time, Baz and I thought it might be fun for us to take a real-world example and see how we might use these capabilities to make implementation of that easier. So we decided to build a new service and a new product for us, which we're calling Witcher. It's a simple video sharing service that you can use to share videos and share and edit videos with your friends and family. You can upload these videos to the service, you can share them, and then your friends and family who you've shared them with can actually play them back very easily. Now, at Amazon, we always start with the customer and work backwards, and we're doing exactly the same thing with Witcher, and there are a few tenets that we want to make sure we focus on. The first and foremost, of course, is user experience. We want to make sure we provide our customers with the best possible user experience, and part of that is the playback experience, right? You don't want to wait for the video to buffer, you don't want any additional latencies, and it needs to be a very seamless experience. But another piece of that is discoverability, right? You should be able to easily find videos that you want to play back. And in order to enable that, we decided to create easy little thumbnails and then make that available for our customers to see. You can hover over or click on the thumbnail and play back the videos that you shared. We also want to make sure that this product scales to millions of users and even beyond. And so as we scale, we want to make sure our user experience does not get compromised at all. So the first thing we do, of course, is build a product roadmap. So we've identified that in order to meet our minimum viable product, in order to launch this successfully, there's a couple of things we absolutely must have. First of all, of course, is scale. This product does need to scale. We also figured that the initial target market for us is the US. So all of our consumers in the US should have the best possible experience. And then eventually we'll look at expanding globally as well. And of course, the experience of creating thumbnails so that you can easily discover and play back your videos. And then after that, we'll start looking at optimizing on cost, and then we'll start focusing on on global expansion, and then also looking at other market segments so we can expand our customer base. And one of the examples we have there is going to be enterprise enablement. So what does it take for us to enable this product and make it enterprise ready? So let's look at a bit more detail in terms of design and the experience that we want to provide our users. So what we want to do is a user, when they record and upload a video, we want to put that in an S3 bucket, but we want to make this video discoverable. And what we want to do is we want to create a thumbnail, and then our application needs to be able to associate a thumbnail with a specific video so you can play it back. And we're going to leverage event notifications for that. We're going to trigger a notification, have a Lambda function triggered, and the Lambda function is going to create the thumbnail for us. It's going to put it back in the S3 bucket, and it's going to update a DynamoDB table that has all the metadata for our application, metadata such as which thumbnail belongs to what video or who this video is shared with. And then, of course, we will be using that. Our application will actually use that to play back the right videos when you hover over that. So let's take a quick step back and see how you might leverage event notifications for something like this. And what exactly is event notification? So event notifications enable you to trigger notifications on specific events. Events like when a new object gets created in your S3 bucket, or now when a new object gets removed, when an object gets removed from your S3 bucket as well. In fact, in addition to adding the delete capability and the ability to trigger an event when an object is deleted and removed, we also added the ability to filter when you trigger an event notification. So not only can you specify the event on which will actually trigger, I can actually control when that event triggers and where that triggers from. So I can specify a prefix within my bucket and say all files with the extension foo, let's say all video files, I only want to trigger notification when a video file gets added to a specific prefix. So that way I have a lot more control over when a specific notification gets triggered, or I can trigger separate notifications and take different actions and have different workflows triggered. And prior to event notifications, a lot of our customers were either building proxy services. So you might be polling your S3 bucket to see if there's any changes, any object that got removed by mistake, or something you didn't expect to be removed, so that you can kick off specific workflows. Or customers are actually writing code to first put an object in S3, wait for it to succeed, and then maybe update a secondary index, for example, or take some other action or kick off some other workflow. With event notifications, my application code is actually super simple. I don't need to write these proxy services. I can simply configure and hook up my event notifications to trigger the right kind of notification, whether it's an SNS topic or an SQS queue where my application might be reading from that queue and kicking off a workflow, or a Lambda function that I might be triggering, which would be code running in the cloud, so I don't need to worry about the infrastructure. I don't need to worry about scale. It will dynamically scale for me, and then it can perform the actions that I need within my application. You also want to make sure that these events are triggered in a performant fashion. And most events are actually triggered within less than a second, so you can kick off those workflows in a timely manner. But most importantly, event notification really enables you to benefit from all the great building blocks that AWS has to offer. So not only can I trigger Lambda, I can use SQS perhaps to put my data in DynamoDB, or use Lambda to put it in DynamoDB. I can leverage the different compute services that I have available, or the different analytics services. It kind of opens up the whole platform for you, so you can wait for a specific event to happen and then hook that up with the right kind of service and the right kind of capability that AWS provides. So really being able to use all of these great building blocks is one of the core values that you get out of event notifications here. Now, I mentioned that you can specify and control when a notification gets triggered, and you can specify the prefix, and you can also specify the suffix, which kind of file I want to trigger the notification for. But there's actually more to it than that, right? You can also decide which event triggers that notification. So not only can I trigger the notification when an object is added via the put API, you can actually specify whether it's updated using post or using copy or even multi-part upload. The same thing is true for delete. You can trigger a notification when an object is removed or deleted. Or if you have a bucket with versioning enabled, if you add a delete marker to your object, event notification would actually get triggered, which you can then use to perhaps build a recycle bin functionality or something, kick off a specific workflow that makes sense for you. So really, it's not just control over when these notifications are triggered in terms of events, but how they're triggered too. So with that, Baz, why don't you show us how we can leverage this to build this Witcher application?
Let's do it. Let's take a look at Witcher version 1.0. This application lets us share videos with our friends and family, like Amir said. So Witcher 1.0, we've got a simple website here. On the right side, I have my list of friends. In the middle, I've got my video feed. And on the left, I can see my videos. And I've got a bucket with a counter of 0. So let's go ahead and put these pieces together and make Witcher 1.0 live. First thing we're going to do is we're going to go to the S3 management console, and we're going to set up event notifications. So I'm going to go down here to events. And I'm going to do this through the UI. So every time a video gets uploaded, I'm going to want to parse that video, read out the metadata from it, store it in my metadata index in Dynamo, as well as generate a thumbnail. So let's go ahead and put those pieces together. So I'm going to create an upload video handler. And then I'm going to subscribe to the object created event. So every time any object gets put in here, this set of code that I'm going to execute is going to run. This year, we added the ability to get very granular also with your event notifications. So instead of a notification handling the entire bucket, I can specify just part of that folder. So I'm going to specify anything that gets put into the video's prefix is going to get processed by this handler. I'm also going to specify an extension. So maybe I want to have one handler for certain types of video files and another one for different types of video files. I don't have to put all that logic in the same place. And then I'm going to send it to Lambda. So a combination of S3 event notifications and Lambda is a really powerful tool that you guys should leverage to build serverless computing. This whole application that we're going to put together is not going to have a single instance, and it's going to be based off of using event notifications, as well as this Node.js Lambda function that we have pre-built. Let's go ahead and save this guy. So now, let me also show you, so I've got a Dynamo table, and this is going to change as videos get uploaded. And let's double check here. It's empty. OK. So going into Witcher, I'm going to share out a video, turn on my camera here, and let's record. Hello, friends and family. All right, so that video is going to upload. And within a second here, hopefully, yep, my put notification is fired. My counter has been updated. And if I go back to Dynamo here, I can see I've got the metadata has been parsed out. I've got a thumbnail record pointer. I've got the thumbnail on the screen here. And if I hover over the video, I can get back and see the video. OK, so that is using put notifications to update a metadata index, as well as generating a thumbnail based off of a new object being created. What we also added this year is the ability to handle delete notification. So an object gets removed, be able to clean up my metadata index, be able to remove the thumbnail that's generated. Let's go ahead and set that up. Rather than using the UI, let's do it from the command line. So I've got a script file here that I'm going to run. And I'm going to use the AWS CLI. So I'm going to call AWS S3 API. And I'm going to call the put bucket notification API call. And I'm going to pass it a JSON file that has additional configuration. So what I'm saying here is I'm going to subscribe. So in the first one, we subscribed to the object created event. Now I'm going to subscribe to object removed. And then I'm going to send that to a different Lambda function that's going to do the cleanup functions that I mentioned, as well as specifying the same types of filters, both on the prefix and the file extension as well. Let's run that guy. Take a second to run. And now, if I come in through the S3 console, I should be able to refresh and see the video that got created. And if I delete these files, then what's going to happen is, hopefully, yep, my delete notification fires. My web app is up to date. Dynamo gets updated. The great thing about this is it allows you to not have to control the entry point. Now you can allow different applications or different subsystems to write to a bucket or delete stuff from the bucket, and you can react to that using the same business logic. Great. So let's see what we could do in the next version of Witcher.
All right, thanks, Paz. All right, so Witcher's out there in public. It's public, and it's doing great. We have over 1 petabyte of storage. Our customers love the product. Now it's time for us to start thinking about how we can optimize on cost. Now, while it's important for us to reduce our storage costs, we still want to stay true to the core tenets that we identified working back from our customers. We do not want our customer experience to be impacted, so we don't want to just make the video slower. The customers see that additional delay when they play back the video. We want to make sure they get the same great experience. And we also want to be able to save on cost. Plus, we also I want my product team and my engineering team to be focused on delivering new capabilities. So I don't want them to be writing code or re-architecting the application just to save on cost. So with these requirements identified, we started looking at our customer data, and let's see how customers are actually using Witcher. And what we see here is that over time, as videos get older, the frequency with which people access and my users access the video and play back the video actually falls, which kind of makes sense. And when I add a new video, a lot of people are sharing it around, they're playing back the video, makes perfect sense. But as they get older, they move on to newer content. And while sometimes somebody would go back and play really, really old videos, like my mom, or the frequency simply just falls over time, and at some point, this data will be ready to be archived. And what we've decided is with Witcher, a year after you upload a new video, it's not going to be gone completely, but it won't be available for immediate playback, and we're going to just archive that data for you. If a customer really wants it, we can work to get that data back for them. So given this usage pattern, let's look at how the new storage class, standard infrequent access, can actually help us save on cost. Now, data over time changes its characteristics, right? As we talked about, and this example is true for a lot of kinds of data, right? Whether you have log data, videos, pictures, what have you, data that is new and is uploaded immediately is hot. It is active data, and a lot of people interact with that data. Over time, the data gets colder. The amount of people and the amount of interaction you have with that data falls until it's ready to be archived. But it's actually a curve, right? It takes some time for data to move from active to be ready to be archived. And that's where the new storage class, standard infrequent access or standard IA, can really help out. It's data that's transitioned from active data, but for some amount of months, days, years, that data will be infrequently accessed until it's actually ready to be archived. And you can actually leverage this new storage class for something like that. So let's look at some of the core properties we thought about when we designed this new storage class. First and foremost, we don't want you to worry about losing your data. That's true with standard. You get 11 nines of durability. That's true with Glacier as well. And the same is true for the new standard IA storage class. You get the same 11 nines of durability that you get with S3 standard. Standard IA is designed for 3 nines of availabilities, 99.9% of the time. When you do a GET request on an object that's in standard IA, it will actually be available. And if it's not, you can do a GET request immediately after, and the data will, in all likelihood, be available for you. But we also wanted to make sure we don't compromise on performance. Now, while this data might be infrequently accessed, when your users want that data, they need it immediately. They shouldn't have to suffer through a lower user experience just because you wanted to move it to a lower cost storage tier. And that's one of the core things we thought about when we designed standard IA, is that your user experience, you get the same great throughput that you get with S3 standard. And it's also very easy to use. We obviously leverage the same simple to use REST interface that Baz will actually show us in a second here as well. And my end users don't see any impact because I don't need to change the API. I don't need to go change how my application actually interacts with the video. And one of the core things there is really that it's the same bucket. It's the same identifier. It's the same key. So I might have an object in standard, and if I move it to standard IA, I don't need to move it somewhere else. It's sitting in the same bucket. My application has exactly the same identifier, the same key. So my application really doesn't need to know that this is in standard IA. And you still get that cost saving and no impact on your performance. Now, of course, security is critical to us. And there's a number of great capabilities that we've added over time in Amazon S3, such as the ability to encrypt your object at rest on the server-side encryption. It's an option. You can easily enable it on any given object. You can also use your own encryption keys that you are managing, or you can use your own encryption key that the Amazon KMS service is managing and use that to encrypt your object. And all of these you can use with standard IA, just like you use them with Amazon S3 standard. Another key piece and key value that we provide, of course, and there's a lot of services that provide this, is really that integrated experience and the ability to easily manage your data both on Amazon S3 and be able to leverage all the different building blocks we have on AWS. For instance, you can use Lifecycle Management to transition your data to a different storage class over time. That works with standard IA just like it does with all the other storage classes. You can enable versioning to really protect your bucket and make sure that you don't accidentally remove something. You can always get back to an older version. Which, by the way, is a best practice anyways that you should do, and that works just as well with standard IA in exactly the same way with standard IA as it does with Amazon S3 standard. Event notifications, we just looked at those. They work with objects that you put in standard IA versus standard, as well as other services. So let's look at the lifecycle management for a second here. So one of the use cases that a lot of our customers are very interested in is as data characteristics change over time. I add a new object, over time it becomes colder, it becomes less frequently accessed. You want it to benefit from this new storage class because your experience will be exactly the same, but it is lower cost. So you can leverage the lifecycle policies in order to do that. You can write a simple lifecycle policy to transition data from standard to standard IA after whatever days make sense for your specific workload. And of course, you can also archive from standard to standard IA to Glacier, just like you can directly from standard to Glacier. We also have expiration lifecycle policies that you can use in tandem with versioning, for instance. So you could enable versioning on a bucket and then write a lifecycle policy to expire objects that are a year older or whatever time makes sense for you, so that you don't immediately remove objects by mistake and you can always recover those. You sort of have a recycle bin functionality there. And of course, you can use this with standard infrequent access as well. But while you have this ability to transition data from standard to standard IA, and it's very useful in a lot of use cases, we're also hearing from a lot of customers that new data that I might not have otherwise saved, such as log data, right? I mean, you have tons and tons of logs, and I barely ever get to those, but when I do get to them, they give me a lot of very great insight. You can now save that directly into standard IA and start saving on storage costs, or perhaps you weren't saving this to begin with, and now you have a very low-cost option to make that data available for your users. So here's an example of a very simple lifecycle policy that I'm writing, and this is what we want to do with our Witcher application. Since we looked at the usage trends for Witcher, we identified that, hey, 30 days from when a video gets created, it becomes infrequently accessed, and so that is when I want to move it to standard IA. So I can simply write a transition rule to say, in 30 days, all of my objects within this bucket, just move them to standard IA. Of course, I don't need to make any changes to my application. It's the same keys, it's the same bucket, but the cost for my storage now goes down because the usage trends and the characteristics of my data actually changed. And of course, I can also write another transition policy to archive that in a year. So Baz, why don't you show us how we can leverage this in Witcher?
Let's do it. So we're back in our S3 console here, and let's configure standard and frequent access for Witcher. It's very easy to do, and what we're going to do, so we were previously configuring events. We're going to go down a few more to lifecycle. And what we're going to do is we're going to set up a new rule. All right, so the rule can apply to the whole bucket or simply a prefix. So we're going to want to filter it down to only the video's prefix and anything inside of there. Next, we're going to configure that rule. And it's very simple. All I have to do is select the first option here. It's going to say transition to standard and frequent access after 30 days since the object was created. All right? In addition to that, I can add another piece of the rule. I can say after a year, we're going to want to send it to Glacier. Right? So I can, and then I could say after another period of time, I can go ahead and delete the file as well and expire it. Right? I'm going to go ahead and scroll down and hit the acknowledgement and review the rule, hit create and activate, and that's it. I didn't have to make any changes to my application. The API is exactly the same, and simply my objects will now be transitioned to this lower cost storage simply by setting up this lifecycle policy. So with lifecycle policies, this happens right after a certain amount of time, right? But I can also explicitly put things in standard and frequent access, things that I might not have been storing in the first place. So I have all these logs, and let's go ahead and set that up. Let's head back to terminal here. So I've got a couple log files here, and what I'm going to do is I'm going to use the S3 CLI, and I'm going to do a cp command, copy, and let's grab one of these log files here. And I'm going to put it into vidshare Oregon, and I'm going to create a prefix called logs. So I can do that, and it's going to go to standard. We also added this new parameter called storage class, and if I specify standard underscore IA, what that's going to do is going to upload it exactly how it used to be in the past. And if I come back here to the console, let's go ahead and find that file. What I see here is this new column here, standard and frequent access. It tells me is this object in standard or in standard and frequent access. So now with both using lifecycle transitions, I can move things over time automatically or put things directly into standard and frequent access by specifying this additional header during my transactions. Very easy to do, lowered my storage costs, and something you should take advantage of if you have the right use case. All right, Omer, why don't you show us how much money we might be able to save with Witcher?
All right. So this is a lower cost storage class, but you want to make sure that, because it's specifically designed for data that's less frequently accessed, you put the right kind of data in the specific storage class. Now I have a very simple example here. In the Witcher example, we said we have about 1 petabyte of storage. If I were to save all of that on S3 standard using public pricing, that would be just a little over 28,000, which is very low, which is very, it's a great price for super high durability, high performance, and high availability product. But my usage trend is changing, right? And videos that are older than 30 days are generally watched less than once a month. So if I were to use that to calculate an estimate on how much it would cost to put it in standard IA, it's just a little over $17,000 a month. So that's over 39% savings. And of course, depending on my usage patterns, it can actually be much higher, up to 55%. So you want to make sure that you identify the right type of storage that isn't frequently accessed and put it in the right kind of storage class. So let's move on. So now we've defined and hooked up our basic application. It's out there. We've reduced cost for our application. Now it's time to start thinking about global expansion. And as we were analyzing our data, we also realized that a lot of our customers in the US are actually sharing these videos with their friends and families who happen to be in Japan. That's the user segment that's popping for us. And true to our user-first and customer-first philosophy, we want to make sure that our new users in Japan also get the best possible experience when they play back these videos. Now, this is where the new cross-region replication capability can really help us. So the cross-region capability simply enables you to automatically replicate all data, all new data that gets added to a source bucket, to a bucket in a different region. Especially in the Witcher example that we're talking about, my data volume isn't high enough to benefit potentially from a CDN. So moving that data closer to my users actually makes sense. Now, when you move this data closer to your users, of course, they'll see lower latencies, and that is a use case we see a lot of our customers. The need for replicating object is being driven by this I want lower latency by moving my data closer to my users. There's also a compliance use case we hear from customers as well. Even though you get the great 11 nines durability and don't really need to worry about losing your data on S3, there are internal compliance requirements people have where I want to replicate data hundreds of miles apart. It needs to be in XYZ regions, and so I need to make these copies and move that data into those different regions. Security is another common use case where I want to replicate data between two different buckets that are managed by separate AWS accounts altogether. So those are some of the use cases, and prior to this, we saw customers writing code or writing proxies to be able to replicate their data, then make sure that all of the data was in fact replicated successfully. And if you start thinking about the scale of S3, if you have hundreds of billions of objects, that becomes pretty complex. With cross-region replication, all you need to do is specify a simple configuration, and S3 takes care of the rest for you. So let's look at some interesting details here. So one very common question we get is, how do I find out the status of any given object, whether that's been replicated successfully or not? You can simply use the head operation on an object to get the status back on replication. Another very common question we get is, well, what happens if I set up replication from one bucket to another, and then from the second bucket to the first one have some sort of an inception thing going there? Only actions that a customer takes on an object is actually replicated. So replicated objects that S3 replicates for you, are not re-replicated. Also, another common use case is, I can turn on cross-region replication and all of my new data is being replicated. That's great, but I also have a ton of data already in the bucket before I turn this capability on. How do I move that? And you can simply use S3 copy API to perform a one-time copy of all of that data. And of course, all of your new data that comes in, cross-region replication will actually take care of that. Now, since we replicate all actions that the customer takes, any changes you make, any updates you make to your source object ACLs will also be replicated. As I mentioned earlier, you have the ability to enable server-side encryption on your object so that S3 encrypts your object at rest. Now, if you have that enabled on your source bucket, that object will actually get replicated to your destination bucket as well. However, if you're using your own encryption keys, those objects will not be replicated because, of course, S3 has no access to those replication keys. In terms of cost, the usual charges apply to cross-region replication for storage, request, inter-region data transfer. There isn't a special charge or specific charge for cross-region replication, but there is a great way for you to save on cost. So if I am replicating, let's say, a copy of my data to a different region for compliance reasons, that data might not be accessed very frequently, so you can actually specify the destination storage class and say, you know what, for replicating all of my data that you put in my destination bucket, simply just put it in standard IA or Glacier, and just archive it and save on storage costs, so you don't need to pay 2x in that case. Now, one of the requirements we have on cross-region replication is that you have to turn on versioning both on the source and destination bucket. And we'll talk more about what the benefit of doing that is in just a second here. But when you do have versioning enabled on your bucket, there's two ways you can remove objects. You can either delete an object without specifying a version ID, in which case what happens is a delete marker gets added to the latest version of your object. It doesn't actually get removed, but of course you can define, let's say, an expiration lifecycle policy to remove older versions. Or you can decide to remove a very specific version by specifying a version ID, in which case the actual version is immediately removed. Now, for cross-region replication, if you delete an object without the version ID, that delete marker is in fact replicated because the object is not removed and you can always get back to it. But if you specify a version ID and remove that object, that action is not replicated. So on your destination bucket, the object will still be there and you have to specifically remove that. So I mentioned we have this requirement to enable cross-region, enable versioning when you're using cross-region replication. Let's look at an example of how this benefits us. And think about this in the context of a distributed system, a large distributed system like S3. So let's say I have two buckets, bucket A and bucket B, and I enable cross-region replication from bucket A to bucket B, right, because I want all of my data to be replicated there, but I also enable cross-region replication from B to A. So I want both of these buckets to be in the same state. So now I add an object called wid1 version 1 to bucket A. That obviously gets replicated to bucket B. I add an object wid1 version 2 to bucket B. That gets replicated to the first bucket. I mean, you know, it makes sense. But what happens when I add the third version in bucket A and then the fourth version in bucket B at exactly the same time? The system needs to be able to handle that. And I don't want to accidentally overwrite an object or a version of the object either. So now that you have versioning enabled, cross-region replication will actually replicate both versions of your object, and you can rest assured that none of your versions will be accidentally overwritten here. A lot of our customers actually use versioning to enable this recyclement functionality so you can recover those files. And then this is a great way where you can have all versions synced between two different buckets and always replicated there. So enabling cross-region replication is very easy, and we'll look at how we can use that in our Witcher example. If you're using the same account, it's actually very easy, and you get to specify even the prefix. So you can say, I want to enable versioning for all new objects that get added to this specific prefix and get that replicated. But you can also have more complex use cases where perhaps my source and my destination buckets happen to be in different accounts. Now, in that case, one of the things you need to do is create an IAM role and then grant the S3 service principal permission to assume that role when you replicate your object. Now, that's important because when an object gets replicated from your source bucket to your destination bucket, you want to make sure that you are the owner of that object, not S3 or not anybody else, because it is, after all, your data. And this is a great way to kind of keep that secured and tied down because you create an IAM role that you own. You specifically provide S3 permissions only to do replication actions on specific buckets. So you always have that control, and you have this explicit permission granted to S3 to perform a very specific action. And at the end of the day, this role is actually the owner of the object that you create and you control. So Baz, why don't you show us how we can use this for Witcher?
For the third version of Witcher, we're going to start here at our operations console, right? So I can see I've got two buckets set up again, one in Oregon and one in Asia, in Tokyo. They're both empty. And let's go ahead and set up replication between these two and see how easy that is. So I can definitely set it up using the UI, but I like to do it from the command line. So I've got a script here that walks through a couple different actions. So the first one is it's going to create a role. And that role is what S3 is going to assume when it's going to operate, when it's going to do the replication. And then I'm going to give that role a policy that allows it to read from one bucket and to write to the other bucket. So I'm going to create a role. That's what S3 is going to assume when it's going to execute this. Once I've done that, then I'm going to set up versioning. I call put bucket versioning, and I turn it on both the source bucket as well as the destination bucket. Once I've got all that set up, then I can call the put bucket replication command. And then I can pass it in the source bucket as well as this JSON file that specifies additional configuration. The most important thing here is the destination. So I'm going to be replicating to Tokyo. I'm going to enable it. I'm going to turn that on, or I could disable it, do the same command to turn it off. And I'm only going to do part of the bucket, just this prefix. Let's go ahead and run it. It's going to go ahead, set up IAM. It's going to set up versioning, and it's going to set up replication for me. It's going to run here in a second. Let's go ahead and make another video. Rather than seeing me again, why don't you guys wave to our friends and family in Tokyo? Excellent. Maybe I should hit the record button on that. Excellent. All right. So now, if everything's set up correctly, same put notification should fire on the left side. Excellent. We've got our video sitting in Oregon, and replication is going to start. So this can take a few seconds or a few minutes, and it's really a function of the size of the bucket, of the object. I see it's completed already. And if I hover over the object, it will play from AP Northeast 1 out of Tokyo. This is a really hard problem to do on your own, right? And with just a couple API calls, I was able to set up replication that's going to distribute my files and objects across the world, all over Amazon's backbone, without doing all the heavy lifting that's involved with doing that before. Now, one other thing that you can do is, so I've got the key for the object here. And if I drop back to the terminal window, I can do a AWS S3 API. I can do a head object command, give it the name of the bucket, so Witcher Oregon, and then I pass it the key. So this year we added a new attribute called replication status, and that will either be pending or completed. So that way I can monitor, if I have a lot of objects, I can monitor to see where I am and how things have replicated. So not only are puts replicated, but also deletes are replicated, right? So if I delete it from Oregon, that will eventually make its way and be replicated into the other bucket in Tokyo. It's awesome. Very, very hard problem to solve, and now with cross-region replication, you can do lots of interesting scenarios to improve latency for your users, maybe meet some compliance requirements that require you to distribute your data across the globe, and we've made that very easy this year. Omer, let's take a look at version 4 of Witcher.
All right. So now that our global customer base is happy, they get the best possible experience, let's look at expanding our customer base. So we've talked to a few enterprises. They're definitely interested in using Witcher to potentially record their videos, training videos, meetings, and then share that with their globally distributed offices around the world. Now, one of the things that a lot of enterprises use is virtual private cloud, the ability to isolate a piece of the AWS cloud for yourself, and then have full control over the network, and then have that isolation within the cloud as well. And our enterprise customers are very interested in something like this. Now, while you could use and could establish connectivity from within your VPC to Amazon S3 prior to this new ability of using VPC endpoints, there were a couple of problems with that. One was all of my data will, in fact, go over the internet when I'm talking to Amazon S3. I would actually have to set up either Internet Gateway or NAT instances, and of course manage those as well to establish that connectivity to the internet and to Amazon S3. And a lot of our customers told us that, hey, you know, I would really like to avoid opening up my VPC to the internet, and since I only want connectivity and I want to run my application to S3, if you can provide, and they wanted secure connectivity from within their VPC to Amazon S3. And that's really what VPC endpoints provide. You are able to very easily configure this and set up secure connectivity from within your VPC to Amazon S3 without having to set up internet gateways, without having to set up and work with NAT instances, and then still get that same high availability and same performance that you want. So this really makes your life simple in terms of not having to manage these additional properties, right? This internet gateway or NAT instances. But not only does it make it simpler, it actually provides higher performance because you don't have this additional hop for your data to go through, right? Otherwise, it would go to the internet gateway or NAT instances, which then routes them to the right location. And now you get to avoid that additional hop with VPC endpoints because VPC endpoints is really a logical entity. But in addition to that, you also get high availability with VPC endpoints. Now, you could do that with, let's say, NAT instances, but you would have to set up multiple instances, and then, of course, that means additional costs and additional management overhead that you no longer need to worry about, and so that also reduces your cost. And then, of course, security. Your traffic and your data is no longer going to the internet. It's actually directly connecting from within your VPC to Amazon S3. So let's look at how that connectivity actually, what that connectivity actually looks like, and what actually happens under the covers when you make a call to Amazon S3 through VPC endpoints. So if you configure your VPC endpoints, you get to write a VPC policy. The policy actually defines which Amazon S3 buckets this specific VPC and traffic from within this specific VPC is allowed to talk to. And you do, let's say, a put request to S3. That REST put request will actually be routed to Amazon S3. But before actually authenticating and authorizing that request, S3 actually gets a copy of the VPC policy and makes sure that this specific bucket that you're trying to access is specified within that VPC policy, and you actually are allowed to talk to that. In addition to that, you can also specify a bucket policy, and the bucket policy would control which VPCs are allowed to talk to this given bucket. So S3 would actually perform a check on that and make sure that the specific VPC that's sending the request is allowed to talk to this specific bucket. And once both of those checks are complete and successful, only then S3 would actually move the request forward and successfully complete that. But of course, you don't go over the internet for this, and you didn't have to manage. You only had to specify VPC policy. You didn't have to set up or manage NAT instances or internet gateways in that case. So really, it's about that control, right? You can write this VPC policy to say, here are the 3 S3 buckets that the traffic from within this VPC is allowed to talk to, nothing else. And then you can go to the S3 side and specify a bucket policy and say, I only allow traffic to this bucket from one VPC, and here's the VPC that I want to allow, and everything else I would deny. So let's look at what that actually looks like. So here's an example of a VPC policy. In this VPC policy, I want to specify actions that are allowed. No other actions would be allowed. And I want to say only gets and puts are allowed from within my VPC. And I only want to put traffic, and I only want to interact with one bucket, which is my secure bucket. Everything else, I want to deny. And then, of course, you can write an S3 bucket policy where you say, you know what, I want to deny everything unless the VPC is this. So in our example, VPC E, 1A, 2B, 3C. So that is the only VPC from where I want to allow successful operations. Everything else, I just want to lock it down. So you get this dual control where you can specify a VPC policy and then work with your bucket policy to get exactly the kind of configuration and the control that you want to establish for your secure connectivity. So Baz, why don't you show us how we're using this with Witcher?
All right, for version 4 of Witcher, what we're going to use is a service called Amazon Workspaces. So Workspaces is a managed desktop in the cloud, and what it does is it will provision Windows desktops that live and actually are sitting inside of your VPC. All right, so I'm going to go ahead and log in. Nice thing with Workspaces is you can integrate it with your corporate directory and have seamless connectivity that gives users private access that's only accessible inside of the VPC. So what I'm getting back here, so I'm logged into a Windows desktop. And let's go ahead and switch back to our console here, and we'll come back to the workspace in a second. All right, so we're going to do 2 things. We're going to set up a VPC endpoint in the VPC console, and then we're going to apply a bucket policy to restrict access to this bucket appropriately. Let's start with VPCs. So I've got a VPC here in Oregon, and on the left menu here, we've added endpoints. So in endpoints, I can come in here and say create. I need to select a VPC. And then here I can specify a policy that's going to restrict which actions are allowed to flow over that VPC endpoint. So this is different than a bucket policy. We're going to get to that in a second. But this policy allows you to say, through this endpoint, I only want to allow gets or puts, right? And then on top of that, the bucket can do additional restrictions. Let's just allow all actions. My next decision point is to apply which route tables do I want to apply it to. And I've only got one in the VPC, so I'm going to pick that one. So I've got an endpoint created. And if I go and look at the configuration, what it looks like is this. So down below in this route, I've got 3 entries. So on the bottom is my default route, 0.0.0/0. All of that traffic is going to flow out to the IGW or the internet gateway, right? The way route tables work is the most specific route wins. By creating an endpoint, what it's done is insert another route here, the one in the middle, that says anything that's going to S3, send it to this VPCE endpoint. So that's a VPC endpoint. So anytime you're trying to talk out to S3, it's going to flow over this route, which got inserted automatically for me. And then I also have, obviously, the default route for the VPC itself. All right, so now let's go ahead. I've got a policy. Let's take a look at this policy here. So this is a bucket policy we're going to apply, and it's got 2 components to it. The first is get object. So I'm going to allow get object for this bucket, and then I'm going to restrict it with the second statement. I'm going to say deny everything unless it's coming from this VPC, unless the source traffic is coming from this VPC. So we introduced this capability when we launched VPC endpoints. I can now apply conditions that say for the VPC, or I can even scope it down to a single specific VPC endpoint as well. Let's copy this guy and go over to S3. And I've got Witcher Enterprise, and I'm going to apply this bucket policy to it. Hit save. All right, so now if I go to, let's find version 3 of our application. So with version 3, now I'm trying to play, this browser is trying to play a video. It's trying to play our sensitive meeting, and I'm connected here to the internet in the Venetian, and I'm getting access denied. But if I switch back over to my workspace, which again is sitting inside of the VPC, and I'm going to go to this address here, and great, permissions granted, the video is able to play, and all that's coming back to me is pixels, right? So I've now built a very secure environment. I don't even need an IGW at all in my route table, and all my traffic is flowing directly from S3 over the VPC endpoint into my workspace here. So this is a great capability that if you want, it lets you also solve, VPC endpoints is also great for simplifying your application, right? I don't need a set of NAT instances anymore. I can simply go directly through the VPC endpoint. So we also added another feature that's very interesting for security-minded folks. So Mary, why don't you tell us about it?
All right. So as we think about scale for S3, right, and we talked a bit about this earlier on as well, one big part of that is really understanding what's going on with your data on S3. How are my users interacting with my data? Who is interacting with my data? When are they doing it? And that's especially important when you think about configurations, right? I mean, I want to make sure that I keep track of who is changing my bucket policies, for instance. And as part of that, this year we announced that we now integrate with AWS CloudTrail service, the service that allows you to track API logs for multiple services, and now you can use that with Amazon S3 as well. So this allows you to track operations that happen at the bucket level that affect your bucket configuration. So if somebody creates or deletes bucket, or somebody changes access policy, lifecycle policy, cross-region replication, ACLs on your bucket, you can actually track those APIs using AWS CloudTrail and get that insight in terms of who made that change, when that change was made, and where was that change made from. So that really additional insight helps you demonstrate compliance, help you improve your security model, and improve security for your data on Amazon S3. Now, another interesting capability that AWS CloudTrail has, and this kind of goes back to the leveraging the different building blocks that AWS has, right, is that CloudTrail integrates with AWS Amazon CloudWatch. And now, since it integrates with CloudWatch, you can actually use the CloudWatch alarm functionality to now get alerted when a specific action happens. So perhaps my lifecycle policy is very important to me. I don't want anyone accidentally changing or by mistake changing that lifecycle policy. And if it does change, I want to be alerted by that. I can simply go to CloudWatch, set up an alarm for a specific API action that's being tracked via CloudTrail, and say, hey, send me an email notification when anybody does a successful put for lifecycle policy or cross-region replication policy, or if somebody deletes and removes a bucket or adds a bucket for that matter. So you get that additional insight and ability to track what is going on with your S3 buckets. Now, you only have to enable CloudTrail once with an AWS account, and all services that support CloudTrail logs for those will start flowing. So if you're already using CloudTrail, you don't need to take any action. Once we launch this, all of your activity that's happening for S3 within that account automatically gets logged within CloudTrail, and you're able to you can today go and see who's making what changes to your bucket level API. Another interesting announcement we did earlier on was launching and supporting storage metrics for S3. So, in the spirit of getting more insight into what is going on in my S3 buckets, you now have these free storage metrics where you can track the total number of objects that are added in your bucket over time. And you can actually use the CloudWatch console to look at different timescales, and you'll see graphs in terms of how that's changing. You can also see the total number of bytes for the S3 standard infrequent access, as well as reduced redundancy storage, and see how the number of bytes for each one of these is changing for any given bucket. You can also, of course, use the CloudWatch alarms and then set up an alarm with a threshold to say, you know what, if somebody is putting more than X amount of objects in my bucket, I want to get a notification, or if somebody is using more than X amount of storage for any given bucket, please send me an email notification so I can take specific actions on that. Now, the CloudWatch metrics are emitted once per day. So at the end of the day GMT, we're going to aggregate that data and emit that specific metric, which would then be available in the CloudWatch console. So you can simply navigate to the CloudWatch console and be able to see this for any given bucket. It's available for all buckets, and it's a free metric. Really going back to listening to you guys, our customers, in terms of what you need to get the most out of your data on S3. So we launched a new storage class that really helps you save on cost. You have the ability to set up cross-region replication, a new service that helps you replicate data from one source bucket to another. We talked about VPC endpoints, as well as additional services that help you get more insight into your data on S3. So with that, we're going to end. If you have any questions, we're going to be around for a while. We also have a lot of folks from the S3 engineering team who can help answer questions that you might have. Thank you so much for taking the time.